Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about instantaneous rates of change.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals 2x squared minus 2, and we want to find the average rate of change over the interval from 1 to 3 halves. Now, we have our graph here. To show we see it's a parabola. Okay. Now I'm going to put the graph away for a moment, and we're going to try to do all the math there and then look at it again at the end. So what we have is we want to find first the average rate of change. So we're given the x values here. We need to find the corresponding y values. So let's go plug 1 in for x, and what do we get? We have 2 times a 1 squared minus 2. Then we want to simplify this. Well, 1 squared is 1 times 2 is 2 minus 2, and that's a 0. Great. Let's do the same thing with 3 halves. 2 times a 3 halves squared minus 2, and this just comes out to be a 5 halves. I won't bore you with that part. All right, so we have our corresponding y values with our x values. So let's go find our rate of change here. All right, that's our delta y over our delta x here. We take our y2, 5 halves, minus our y1, which is 0, over our x2, 3 halves, minus 1, or x1. Simplify that out. We have 5 halves over a 1 half. And that simplifies to be a positive 5. So our average, right here, the average rate of change is 5. But we also want to find the instantaneous rate of change right here, the instantaneous rate of change. Well, to do that, we have to use our definition of our limit here. So what we're going to do is take the limit, all right, as h approaches 0 of our, we're going to find f prime of x here. Let me shove that in. Okay, of our function. Now, our limit says we take our function to, we have an x, instead of an x, put an x plus h in, squared, minus 2, minus our 2x squared minus 2, like that, all over our h value. And now what we're going to do is we'll simplify what we can in the numerator. We have the limit as h approaches 0 of, this thing simplifies, we have a 2 times an x squared plus a 2xh plus an h squared, minus a 2 minus 2x squared, distributing this part out, plus a 2, all over h. Let's keep going. It's a lot of writing of limits here, but don't worry, eventually in calculus you won't have to write that out every time. You'll learn something new. Well, we have 2 times x squared, we distribute this out, so we have a 2x squared plus a 4xh plus a 2h squared minus a 2 minus a 2x squared plus a 2, all over h. All right, so now here I'm going to try to cancel out what I can. Well, I see there's a 2x squared and a 2x squared right there, negative 2 and a positive 2. And actually I can cancel out some of these h's. We have an h here, cancel out this h and this squared. So we're left now with the limit as h approaches 0 here of what's left over is just 4x plus a 2h. It's now at this point that we can take the limit by plugging 0 in for h, and we have 4x plus 2 times 0, which is just a 4x. And that's equal to our f prime of x. Now they tell us that I want to use the leftmost value of our given interval. So that's a 1. So to do that, we have f prime of 1 here, we're trying to use here, and that's 4 times 1, which is 4. And so our average is 5, our instantaneous rate, if I can spell, is 4. And again, our graph, I'll put it back up here, but there's our graph for our function, and at the interval from 1 to 3 over 2, the x values there, our average rate of change was 5, but right there at 1, the instantaneous rate of change is 4. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.